Okay, today in honors algebra, we didn't start factoring quadratics. We kept factoring quadratics. We've been factoring quadratics for a day. Now we started that yesterday. Now we're going to keep factoring quadratics. We didn't really introduce too many new things in class today, so I'm just going to go ahead and work a few problems off the homework tonight. And we're going to start by working number 21. Number 21. 21 says, and you can read this in your own book, 21 says, the sides of a square all increase by 3 centimeters. The area of the new square is 64 centimeters squared. Find the length of the side of the original square. Okay, I have an original square. Each of the sides is x. What I'm going to do is I'm going to increase this by 3. This is x plus 3 now, and this is x plus 3 now. What it tells me is that the area of my new square is 64 centimeters squared. So I'm going to take x plus 3 times x plus 3, which is x plus 3 squared. That would give me the area of the square, and it told me that's 64. This is like one of yesterday's quadratics. Since this is squared, drop the square root, drop the square root. X plus 3 equals plus or minus 8. Subtract 3 from both sides. X equals negative 3 plus or minus 8. And negative 3 plus 8 is 5. Negative 3 minus 8 is negative 11. I ask myself, because this is a real life problem, can I have a square that has a side of negative 11? Does this make any kind of sense? It doesn't. I'm going to get rid of that one. But I will take this 5. That means this was 5 plus 3. That means the original side of the square was 5. Make sure I've answered the question. Find the length of a side of the original square is 5. Done. Let's look at, we looked at number 23 in class, so I'm not going to worry about too much about that one. Maybe 25. 25. The product of two consecutive numbers is 14 less than 10 times a smaller number. Find each number. Oh my goodness. Find the product of two consecutive numbers. When I see two consecutive numbers, my two consecutive numbers are x. If I want the next one, it's x plus 1. And it told me the product, so I'm multiplying here. It told me that the product of these two consecutive numbers, my consecutive numbers, is 14 less than 10 times the smaller number. Okay, 10 times the smaller number minus 14. 14 less than 10 times the smaller number. I now have a quadratic equation because I distribute and I get x squared plus x equals 10x minus 14. This is easy solving now. Subtract 10x from both sides, add 14 to both sides, and I'm going to get x squared minus 9x plus 14 equals 0. This should be easy to solve. I'm going to get x minus 7, x minus 2 equals 0. Zero product property says we can say x minus 7 equals 0, which says x equals 7, or x minus 2 equals 0, and x equals 2. My two solutions, x equals 7, x equals 2. What this means is either of those numbers should work. So 2 and 3 should work because this is a smaller number, so 2 and 3 should work. We can check that. 2 times 3 is 6. 10 times 2 is 20 minus 14 is 6. It works. 7 times 7 should also work. So 7 times 8 is 56. 10 times 7 is 70. 70 minus 14 is 56, and they both work. So both my answers are going to work. Let's try another homework problem. You have a few problems tonight that just look long but really aren't that bad, like 31, for example. 31 says 4x squared plus 20 is 10x plus 3x squared minus 4. What do I want to do? I want to put this in standard form. So I'm going to subtract 3x. I'm just going to bring everything over here. So I'm going to subtract 3x squared first, minus 3x squared. So I get x squared plus 20 equals 10x minus 4. Next thing I'm going to do is I'm going to take these 10x to the other side, just because I want this in standard form. Really, as I get used to this, I'm just going to do all this at the same time, and I'm not going to spend this much time going through this. X squared minus 10x plus 20 equals negative 4. I'm going to add 4 to both sides. X squared minus 10x plus 24 equals 0. Factor this. X minus 6, x minus 4 equals 0. Zero product property, solve. x equals 6, x equals 4 by the zero product property. There's my two solutions to number 31. Let's try another one. I'm going to look at 37. And here it is. 37 says solve x squared equals x and x squared equals negative x by factoring. What number is a solution to both equations? So I'm going to write down both equations. X squared equals x squared equals negative x. Here's what you should be thinking when you look at this problem. Regardless of the problem and how it looks, it's a quadratic. If it's a quadratic, bring everything to the same side. Minus x. X squared minus x equals 0. Over here, add x, x squared plus x equals 0. I want to factor this guy. What is that? What can I factor out? I'm going to factor out a GCF because there's a greatest common factor here. I'm going to x times x minus 1 equals 0. Over here, you have the same GCF. I'm going to take out x. I'm going to get x plus 1 though equals 0. Make sure you know why that's an x plus 1. Zero product property here says x equals 0 or x equals 1. Here, x equals 0 or x equals negative 1. And the second part of the question said which one has the same solutions. Here's your solutions to both problems. What's the one they both have in common? This x equals 0. Not too big a deal. I'm going to skip down here to number 39. 39 says x to the third minus 5x squared plus 4x equals 0, and it says factor. You look at this problem, you go, I don't know how to do a cubic. It's a cubic because it has a third term. We only can do things with squared terms. We could do that. We can't do this. But we do know how to factor out GCF, so we're going to try that. We're going to see, and if you look at the example on this page, it does say factor out a GCF. We're going to take out the GCF, which is x here, times x squared minus 5x plus 4. I can factor this now. That's a quadratic. It's x times x minus 4 times x minus 1 equals 0. Zero product property, x equals 0, x equals 4, or x equals 1. And those are my three solutions. Notice a cubic has 3 solutions. Quadratics had 2 solutions. Cubics 3, quadratics 2, and then we can keep on moving on. The last problem you had to do today is 45, and 45 says that we want to find an equation that has the given numbers as solutions. For example, 4 and negative 3 are solutions to x squared minus x minus 12. We did like one of these on the opener today. I'm going to do an easier one with fractions, without fractions, like B. I have solutions of 3 and negative 2, and we'll start this one. Here's my solutions 3 and negative 2, and I'm going to work backwards because I want you to see what this would look like. My solutions are 3 and negative 2, and I was working backwards. This would be the last step in my problem. X equals 3, x equals negative 2. The step before that would have been zero product property, which means I would have had x minus 3 and x plus 2. I then would have written these as factors. X minus 3, x plus 2 equals 0. Notice this just looks, if I factored this, I'd set each of those equal to 0, and I would solve. Now we're working backwards. We started with this, we went to here, we went up here to my factors, and then all I want to do is multiply this together. So I'm going to get x squared. You distribute everywhere, minus x minus 6. I already combined the like terms in my head, so there's your answer. This should get you all the way through the homework, and this gets us a good start on factoring quadratics. It's our only tool to be able to solve quadratics right now is factoring. Eventually, in the next few days, we'll be doing more than factoring. We'll learn some new techniques, but for now, all we can do is factor, so that's all we're going to do.